For the rational function f of x equals 2x plus 6 over x minus 4, determine the coordinate of the x-intercept, the y-intercept, any equation of vertical asymptotes, horizontal asymptotes, and finally graph the function. Okay, so these problems, they sound like a lot to do, but as long as you know the properties of these, it's really not. X-intercepts occur whenever the numerator is equal to 0. So if I take 2x plus 6 and set that equal to 0, I get 2x equals negative 6 or x equals negative 3. So I have an x-intercept at negative 3, 0. And I can go ahead and graph that. Just go ahead and plot that point. All right, y-intercepts, those are pretty straightforward as well. It's just going to be the ratio of constant terms. So it's 6 over negative 4, which becomes negative 3 halves. And it's the point, actually, so I'll write it as 0, negative 3 halves. So 0, negative 3 halves would be like 0 and negative 1.5. Okay, the horizontal asymptotes and the vertical asymptotes, those are not too bad either. Horizontal asymptotes, we just need to know the rules of determining those from the degrees of the rational function in question. So the degree of the numerator is 1, the degree of the denominator is 1. So the horizontal asymptote, since the degree is equal, is going to be y equals the ratio of the leading term coefficients, and that's 2 and 1 in this case. So just y equals 2. So that means we have a horizontal line, and I'd use dashed line because it's not actually part of the graph, it's just telling me where it's going, at 2. And vertical asymptotes, the equations of the vertical asymptotes occur whenever the denominator is equal to 0. So we just set that denominator equal to 0 and solve. So at x equals 4, and we do leave that as the equation of a line because it is happening at a line. Okay, now the last thing is to fill in the graph. So the graph is going to bend toward the asymptotes. So either this will be my graph or something like this will be my graph. So I have to determine which lines, to pick from. So the asymptote is going to guide this curve somewhere. So it has to eventually end up at this line, and it has to go to positive or negative infinity here. Well, because I have these 2 points already in this lower portion, that's telling me that the lower portion is the correct portion of this graph. So I'm just going to make sure it ends eventually here and passes through these points that are known. Okay, and then similarly, on the other side, the graph has to bend toward these asymptotes, and it's either going to be this upper region or this lower region. The thing is, I don't have an additional x-intercept here, so there's no way it can be this portion. So that means the rest of this graph is going to be this upper region and look like this. Now, you don't have to go and determine other points of interest to plug in to make this any more accurate. As long as you have x-intercepts, y-intercepts, and asymptotes, you're all set.